we know that square root of 25 is 5, right? Well, because 5 squared is 25. So square root is the reverse iteration. Okay, but then how about square root of negative 25? So we came across situations where we had to take square root of a negative number. And do you guys remember what we said in that case? So what did we say? It was on the last week homework, yeah. So when we had square root of something negative, what did we say? That's how we came across, or we figured that should be the answer. We said, well, what number when I square gives me negative 25? And of course, we just checked that 5 squared is positive 25, so that's not what we need. And if we try negative 5 squared, then we get negative 5 times negative 5. That's also positive 25, and that's not what we have, right? Remember how we tried numbers and we figured, well, actually nothing works, right? No number from the number line. When we square that number, gives us negative 25, and we said that square root of negative 25 or square root of something negative is not a real number. Remember that wording is not a real number. And that's where we stopped last week. Well, this week, we're going to be able to continue, and actually what we're going to say, or that's actually our topic today. Here I'll continue. Square root of negative 25 is not a real number, and it's still true, but it's a complex number. But it's a complex number. So it actually equals to something, and that's what we're going to find out right now. So the topic for today is, let's see, let me use bread. The complex, I want to have something on my screen. What is that? Did I press on Dropbox? Can you see, guys, something weird on the screen? If I close that, not like that. Okay. So the complex number system. Okay, so what does it mean that square root of negative 25 is a complex number? Now, this is what it means. I can take square root of negative 25, and inside the radical, I can express negative 25 as the product of negative 1 and 25, right? So negative 25 is the same as negative 1 times 25. And we already know that when we can split up number inside the radical into a product, well, the entire radical can be split up. So we can say that's the same as square root of negative 1 times square root of 25. Well, now we know that square root of 25 is 5. So that is 5. But what is square root of negative 1? Well, that's where everything comes together to the complex numbers. Square root of negative, like in math, I guess I should kind of say in general in math, square root of negative 1 is defined as I. Now, I is not a variable. It's like a special symbol. In this case, I mean, it's a letter I, but it's a special symbol that defines square root of negative 1, and it's called imaginary unit. So I'm going to box that because that's going to be kind of like the key definition here. And I is an imaginary unit, and that's why we use letter I. Imaginary unit. So I stands for imaginary, and it's called imaginary. Well, the word imaginary is used because, once again, in the real, when we look at the real numbers, and real numbers, you just can think like about the ruler or numbers that we use in real life to measure things, to weigh things. we cannot take square root of a negative number. So there's nothing that works from real numbers. But well, in math, and things can go, you know, pretty crazy in math. So we have this imaginary world, or some parts of math are imaginary world in a sense. And there, in that world, we can take square root of -1, and that equals I, well, imaginary unit. So you can kind of like have to accept that as the fact. And oh, and then let me finish, I guess, and then I'll add something else here. Well, then now, as I found that out, that square root of -1 is I, well, it means that here I can put I right here next to 5, right? So square root of -1 is I, square root of 25 is 5. So, and now I have I times 5, and that can be written as 5I. So I can just change them places. So if I have like x times 5, I can write 5x. So same idea. So I can write 5I. Well, and if I kind of write it in short, so I can say that square root of -25 is 5I. And 5I is the complex number. Complex number. So like that. Now, before we move on, and I'll talk about complex numbers further, let me go back to that definition that I have right here, that the one I have in red, and let's add one more box. So I'm going to put one more box over here, and in that box I want to put the following. So what happens if I take square root of -1 equals I and I square both sides? And we can try it here on the side. So if I take square root, well, I know that it was just given to us that square root of -1 equals I, right? What happens if I square both sides? So it's like a little, I don't know, it's an equation equality, right? So I can square both sides. On the right-hand side, well, I squared is I squared. What is on the left-hand side? What is square of the square root of -1? What is it equal to, the left-hand side? Anyone? So we already came across stations where we had to square roots. Actually, on Monday during a lecture we had, we did talk about that. So what happens when we have square root and square right next to each other?
Doesn't it just become a positive?
So when I know what I think about. So when we square something negative, right, and we kind of have something negative here, yeah, that becomes positive. So that, you're right. But besides the fact that we have -1 here, we also have square root. So that -1 is sitting inside the square root, right? So what happens when we have square and square root right next to each other? Well, they cancel each other out. So square root cancels square, or square cancels square root. So they square each other out, and that means that we're only left with what was sitting inside the square root, which is -1. So in this case, it stays negative, just because those two operations cancel each other out. So it's negative. It's still -1. The rule I used here is that when you have anything inside the square root and that's squared, then it's just that number. So that's the idea. So, and then what we produced right now, it's actually going to be something that I'm going to put in the box. I'm going to say that I squared, I'm just changing the order, I squared equals -1. And as we move on, we'll need to remember that. So I squared, when you see I squared, it can be just replaced with a number, -1. Now, right now it may, it's probably like, okay, why, what are we doing here? So it will make sense as we start, working with complex numbers. But for now, let's keep those two in two boxes. A few more notes about like kind of theory behind complex numbers, or so complex. It's not changing the color. right here, complex number. So complex numbers, they actually, even though 5i is a complex numbers in general, they have special form. They have two terms involved. So they have this form, I plus bi. Okay, so that's the form of a complex number. Now, what is a plus bi? Let me just give you actually an example. So here's an example of a complex number. I know 5 plus 3i. So even though you see two terms, this whole thing, this whole expression is one complex number. So complex numbers have two parts, and they have what's called real part. This is a real part, because it's always just a real number. 5, 7, it can be a fraction, it can be a radical square root of 2, but it's something that you can find on a ruler in a sense, well, or on a number line, I should say, because we don't really have usually fractions, or we don't label ruler with fractions or radicals, but like number line, right? So numbers you can find on number line. And then the second part is called imaginary part. Imaginary part. And that's the one that's with I, with an I. So 5 plus 3i, 5 is the real part, 5 is the real part, 3 is imaginary part. All together it makes a complex number, 5 plus 3i. Here's another example of a complex number. Negative 1/2 minus square root of 2i. It's also a complex number. Again, the whole expression of the complex number, it has two parts, the real part and the imaginary part. This one real, this one imaginary. Now, why we only had 5, like why did we say that 5i a complex number? So right here at the top, remember we said 5i is a complex number. Well, even though we said the complex numbers have this form a plus bi, so they have to have two terms. Well, because 5i, I can write as 0 plus 5i, right? So if I want to write the standard form of a complex number, well, that's how I can write it. 0 is the real part, and then 5 is the imaginary part. But I don't really have to place 0, so I can just simply write 5i. So in some cases, it's going to be only one term. It means that the other part just equals 0. So that's what we're going to be looking at. Do you have any questions so far? Because that, like, we're kind of done with the introduction. So what's going to be left for today is to talk about how to perform operations with complex numbers. So we're going to talk about how to add them, how to multiply, well, add, subtract, how to multiply complex numbers, and how to divide complex numbers. And actually, you'll see that it's not that hard to do those operations. So how to add or subtract complex numbers. And let's just do a few examples. So for our first example, let's say we have, let's use that number ahead on the top, 5 plus 3i, that's the first complex number, and I'm keeping it inside the parentheses just to kind of emphasize how it's one complex number. And let's say I'm adding another complex number, 1 minus 2i, like that. So I'm adding two complex numbers. Well, when I'm adding two complex numbers, I should get another complex number. So this algebra of complex numbers works kind of like, oh, Erica, I see your response now in the chat. They kind of work same way. So you add two numbers, you get another number. Multiply, divide, and you get, new number. To add, you simply have to, let me write steps. So step 1. Clear the parentheses. Clear the parentheses. Now, we're going to clear parentheses same way as we already know how to clear them out. kind of following same rules. So, and the rule is that if there is nothing in the front of the parentheses, we can simply drop it. We can just, get rid of the parentheses. So for example, there's nothing over here in front of the first set of parentheses, so I can just literally remove them and nothing is going to change. And in the front of the second set of the parentheses, second number, again, I don't have any numbers and I have a plus sign, right? So since I'm adding, I have a plus sign. That means that I can just simply drop the parentheses and I'm not gonna change anything. So it's gonna be plus 1 minus 2i. So when it's addition, it's super easy because remove the parentheses with no changes. Now, after you remove the parentheses, the official step is next. Combine real parts and combine imaginary parts. So combine real and imaginary parts. Now, what are the real parts? The real parts are 5 and 1, right? Well, I'll combine them. 5 plus 1 is 6. And what are the real parts? On the imaginary parts, it's 3i and then minus 2i. Well, 3i minus 2i is just 1i. So I can write 1i or just I, right? So I can rewrite as 6 plus I, like that. And that's another complex number that we obtained. So we added 2 complex numbers. Well, here's a new complex number that we ended up with. So that's kind of like the official step, combine real parts and imaginary parts. However, like the shortcut is just to think in terms of combining like terms. That's pretty much same idea. Even though I is not a variable, it's not like it can be different, it can be equal different things. So I is imaginary unit and it always equals to square root of -1. We still can treat it as the variable, or kind of, yeah, when we do operations, for the most part, we can treat it as the variable. So in other words, 3i and 2i can be combined together, and 5 and 1 can be combined together. So yeah, thinking in terms of like terms is helpful. Because let's try now subtraction. So let's say I have -3 plus 7i minus 2 minus 4i. Like that. Again, I'm now subtracting because, well, obviously there is a minus sign. I'm subtracting 2 complex numbers, and they're inside the parentheses. Now, steps are the same. So step 1, clear the parentheses. Now, this time we have to be careful how we clear the parentheses. In the front of the first set of parentheses, I don't have anything. Again, right? Well, it's the beginning of the expression. So that means that I can simply drop the parentheses for the first complex number, and all signs will be preserved, all numbers will be preserved, so I'll have minus -3 plus 7i. Now, when I move on to the second set of parentheses, I notice that in the front I have negative sign, well, because I'm subtracting. And that means that this time, to clear the parentheses, I have to distribute that, well, I can say distribute the negative sign, or that is the same as to think. And again, that's kind of all the prerequisites, so most likely you're already familiar with that. If not, then, well, here we are talking about things like that. This rule applies to all situations where you have parentheses with a minus sign in front of them. Yeah. So you have to distribute that minus sign. It's the same. You can think about it as multiplying everything by -1. So in your mind, you can imagine how it's -1 here. And I am multiplying everything by -1. Well, -1 times 2 is -2. And -1 times -4i is +4i. And that's how the parentheses will be dropped. And the shortcut to that is just to notice that what happened to the original numbers is that they just changed their signs. 2 used to be positive, now it's negative. 4 used to be negative, or 4i used to be negative, now it's positive 4i. So when we have negative sign and we distribute again, what it does is just changes or flips all the signs or changes all the signs to the opposites. Do you guys have any questions about how I clear the parentheses? No questions. Okay, then let's move on because, well, we're almost done here. We clear the parentheses and now we just have to combine real parts and imaginary parts. It's the same approach as if you were combining like terms. So you would combine -3 and -2. That gives you -5. And then you will combine 7i and 4i. 7i and 4i. 7i and 4i, that's 11i plus 11i. Again, those two we will not combine. Think about them as unlike terms, but they are real part and imaginary part of a complex number. Altogether, they make a new complex number that we obtain after we add, subtracted two numbers. Notice that, well, when we add, subtract real numbers, we kind of already know what to expect, right? Number will be like bigger or smaller, right? We can kind of compare numbers, original numbers with the result. Well, when we work with complex numbers, there is no way to actually compare complex numbers. So that's something that's different. Well, when we work with real numbers and complex numbers, we don't compare, we don't say which one is bigger, which one is smaller. So there is no way to compare complex numbers when we, as with real numbers. But there is a way to add and subtract them. So that's the addition subtraction. Do you want to see another example, or it makes sense? So do you want to see more examples for addition subtraction? So tell me yes or no for seeing more examples. Okay, yeah, good, because I think, yeah, that's pretty self-explanatory. Okay, well, let's then move on to multiplying complex numbers. So how to multiply complex numbers. How to multiply complex numbers. Let's do a few examples. Okay, so let's say I need to multiply 5 minus 2i, that's the first complex number, by the complex number -1 plus 3i. And see, I'm writing into multiplication by just gluing together, putting two numbers right next to each other. Remember, when there's nothing in between. So at this point, it's going to be important not to confuse, I know, addition, subtraction with multiplication. So here I have nothing in between the parentheses. There's nothing written, so it means that it's multiplying. If you see plus or minus in between the parentheses, like in the previous two examples, see how we had minus in between. So right here we had minus inside in between the parentheses. Here we had plus in between the parentheses. Well, that's addition or subtraction. So that's the difference. Okay, how to multiply? Again, we're gonna kind of think that or treat I as the variable. Well, if I was the variable, how would we multiply expressions like that? Well, we would have to FOIL, right? We would have to take 5 multiplied by everything inside the second parenthesis. And then we would have to move on to -2i and also multiply it by everything inside the second parenthesis. So we already had similar situations. And again, yeah, that's how we're going to do it here. So 5 times -1 is, well, since this is our first example, let me write things out. For the future examples, we maybe can skip this step. But first, it's 5 times -1. Then it's 5 times 3i, like that. Then it's -2i times -1. And then I'm following the last arrow, so it's -2i times +3i, like that. So I followed all those arrows, and that's what I got. And now I'm going to perform multiplication. So nothing fancy here, no tricks. except like one little trick at the end. But so far, everything works the way you know it. So 5 times -1 is -5. 5 times 3i, you just go ahead and multiply numbers, so it's plus 15i. Next, it's -2i times -1. So negative times negative gives me positive, plus 2i. And then the last one, so here you have to be careful. So you will multiply the numbers, 2 and, well, -2 and 3, that's -6. And then don't forget to multiply i's, because it's 2i and 3i. So I and I will have to be multiplied. Well, when you multiply anything by itself, you get things squared, right? So it's -6i squared, like that. Do you have any questions about where I got all those terms from? Okay, so Nancy, you're good. Does anyone else have any questions? Marina, good. Marisa, no questions? Okay. Okay, then let's move on, because what's left to do is the following. So what's left to do is to combine, well, I'm going to say like terms, but it's like combining imaginary parts in this case, because I can see here how 15i and 2i can be combined, right? That's one thing. So I think this is this one is obvious. Well, and another important thing is that you have to do is to remove this, or I should say replace I squared by, do you guys remember what I squared equals to? We had it in the box at the top.
-1.
-1, very good. So yeah, I wanted to see if anyone remembers before I move up to here. So remember how we figure out that if square root of -1 is I, well then I squared has to be equal to -1 through this just basic algebraic manipulation. That's right. So I squared is -1, and every time when you perform this kind of operation like multiplication, every time you come across I squared, you have to replace it with -1. So the answer should not have I squared, because we know that the complex number in its standard form, it has this form, and it's a plus bi, right? So see, it doesn't have any I squared. And that's how the answer should look like. I mean, we may be missing one or another part of that sum, but we shouldn't have any I squared present. So that's -1. So that means that this is what I'll have. -5 plus 15 plus 2, 17i. And then now I have to be careful, because I'm going to write -6. Well, since it was -6i squared, it used to be multiplication, right? 6 and I squared were multiplied. Well, it means that everything should stay multiplied here. And as I replace I squared with -1, it has to be multiplied by -6. So that means that I will have -5 plus 17i, and then -6 times -1, this part gives me +6. So +6. And then to finish this, I will combine -5 and 6. That gives me 1. So real part I'll put in the front, +1. That's the real part. And then plus 17i, that's the imaginary part. All together, that forms one complex number. That's the result of the multiplication of two other complex numbers. So that's the final answer. We can also have a situation where we're multiplying complex number that only has imaginary part. So 2i, well, 2i is the complex number. It's just missing the real part. It equals 0. If we have to multiply it by 5 minus 3i by this complex number. So this is complex number 1. This is complex number 2. And we're multiplying since they are glued together. They're right here, nothing in between them. So to multiply, it's just, just think in terms of distributive properties. So we'll have to distribute 2i, multiply 2i by 5 and by -3i. So when I multiply 2i by 5, I get 10i. 10i, right? 2 times 5 is 10. And then when I multiply 2i by negative 3i, so first of all, sign is negative. Positive times negative gives me negative. 2 times 3. 2 times 3 is 6. But then don't forget to multiply I and I. So in general, when you're multiplying two complex numbers, you will end up with I squared. And if you're not seeing I squared, well, something is off. Go back and recheck. And it's a common mistake to forget to write I squared. So I'm just kind of like warning you that it must be there. So I squared should be there when you multiply two complex numbers. You cannot avoid it. But since you will get I squared every time, then you need to remember to replace it by -1. So I squared equals -1. Somehow we end up with -6 and -1 again. This is just a coincidence. So then I'll have 10i, and then -6. Now I know that it has to be multiplied by -1, which is 10i plus 6. And even though, that's the complex number we get as a result, what I'll do and what I'll box, I'll switch the order here. So I'll put the real part first and then the imaginary part, just so it looks like a standard form of a complex number like that. Technically, it's not a mistake to keep them in that order, unless it says, well, put complex number in the standard form. Then you want to put real number first and then the imaginary part. So that will be the answer, like that. So let's try now one more example, and we'll try to multiply 3 plus 7i, this complex number, by a complex number 3 minus 7i, like that. So that means that I'll multiply 3 by everything inside the second parenthesis, and then I'll go ahead and multiply 7i by everything inside the second parenthesis. Let's see, and now again I will let's try to skip that middle step where I write out products, and just go ahead and perform multiplication. So it's 3 times 3, that gives me 9. Then it's positive 3 times negative 7i. Positive 3 times negative 7, it's negative 21, and then I have I right next to it. Then I move on to 7i. 7i times 3, that is positive 21i, like that. And the last product is 7i times negative 7i. So 7 times negative 7, it's negative 49. But then I times I gives me I. Keep pressing something. Okay, here it's I squared, right? And again, I'm making sure that I squared appears somewhere in my result here. Okay, so here it is. So we foiled it, and now we're gonna combine same types of parts. So it's like combining like terms, and we're gonna take care of that I squared. I squared we're gonna replace by -1. Now, when I look at the middle terms here, so I can see that negative 21i and then positive 21i, they're opposites, right? One is negative and one is positive, so they are opposites. It means that we can just cancel them out. I'm left with 9 minus, and then I like to write this step out, negative 49 times -1, because when I write it out, this way I get the correct sign. So this step, or the common mistake for that step where you replace I squared with -1, is to mess up the sign. So just be extra careful with the sign that you're going to get. So to help you write things out like this way, because now I can see that it's going to be 9 plus 49. Negative 49 times -1 is positive 49. And that is 9 plus 49, 58. So this is what we got. Now, what happened is that we multiplied. So this answer is kind of different from what we got in the first two examples. In the first two examples, we multiplied two complex numbers. We ended up with a complex number. This time we multiplied two complex numbers and we end up with a real number, 58, right? See how it doesn't have this imaginary part? It doesn't have I involved. So it's a real number, real number. Real number. Now, why did that happen? What do you think is so special about this example that somehow we end up with a real number, not a complex number at the end? Can you notice anything special?
Because we canceled out the middle terms.
We canceled out the middle terms. That's right. Exactly. Why do you think we were able to do that? Why we couldn't cancel out the middle terms, let's say in the first example, but we were able to cancel them in this example. So why did that happen?
The negative and the positive and being the same numbers.
That's right. So that's exactly. If you look at the original complex numbers, then they look almost alike, right? Except one has plus and one has minus in front of that imaginary unit, right? So 3 plus 7i, and the other one is 3 minus 7i. Well, these are two different complex numbers, but they're very similar. And in fact, they are related. They're called conjugates, well, complex conjugates. So those two numbers, 3 plus 7i and 3 minus 7i, are complex conjugates. And then in general, complex conjugates have this form: a plus bi and then a minus bi. So when signs are different in front of the imaginary units right here, those two are complex conjugates. Let me write down this complex number, 3 plus 2i. What is the complex conjugate of that number? So what I put next to it, and then I'll put one more example. If it's -5 minus 9i, what would be the complex conjugate? Okay, so let's do one at a time. In the first case, so if it's 3 plus 2i, what is the complex conjugate?
3 minus 2i.
3 minus 2i. That's right. Okay, very good. And then in the second case, if it's -5 minus 9, -5 minus 9i, what will be the conjugate of that? What do you think?
Would it be -5 plus qi?
Right, that's right. -5 plus 9, this is 9, sorry. It does look
My
like
bad.
-5 plus 9i. And very good. So you said it exactly right, because even though 5 is also negative, you don't change its sign. So -5 stays as -5. It's only sign in front of the imaginary part that you change. Very good. So you did exactly right. Okay, perfect. So now let's multiply. Multiply the first one, kind of like the same way we did before. So let's distribute. And then, just for the practice sake, and then I'll show you the shortcut. So 3 times 3 times 3 gives us 9. Then it's 3 times -2. 3 times -2i minus 6i. Then I'm doing 2i times 3. That's positive 6i. And then finally, 2i times -2i. Positive 2 times -2, that's -4. And then I times I is I squared. Like that, I squared. As we can see here, yeah, the middle terms cancel out, -6i, positive 6i. Now, I squared we will replace with -1. So that gives us 9 equals 9. And then, well, maybe here I'll do it quicker, a little bit quicker. So -4 times -1 gives me +4, right? Negative times negative is positive, so +4. And that is 13. Okay, yeah, so we got just a real number when we multiply those two conjugates. That was our way before. Now, what would be the shortcut? The shortcut is the same one as we use when we work with the radicals. So if you remember, we have this like a formula that says that if we're multiplying, formula that we learned back then when we learned factoring. But the way we use this formula now, we're saying that if we have sum of two things, they could be two numbers, variables, parts of the complex number, so I'll say things. When you take sum of two things and you multiply by the difference of those same things, that is same as squaring the first one. So a squared, and then minus, it's always minus, b squared, so the second thing squared. And I want to emphasize that it's always minus. Always minus here. And that's what we have. So when we multiply two complex conjugates, well, that's the setup we have, right? 3 plus 2i, it's like a plus b, times 3 minus 2i, it's like a minus b. So that means that another way to multiply them, I'll say or equals, is to use that formula. So I have to take the first thing. So the first thing in my case is 3. So I'll put 3 squared. Then I put minus, it's always minus. And then I'm going to take second thing, that's 2i. So 2i, and I have to put inside the parentheses to emphasize that the whole thing is being squared. And now as I square, so 3 squared, I know it's 9, minus, well, the second part, that's where I have to be careful. Remember the laws of exponents. If I have a product that's being raised to the power, each factor gets squared or get to be raised to that power. So it's both 2 that I have to square and I that I have to square. So 2 squared is, of course, 4. And then I squared is, well, I squared, so minus 4. And that minus, I just carried over right here. It's not being squared, right? See, it's outside of the parentheses. So it's 4i squared. And of course, here, to finish this, I have to do the same thing. I shouldn't leave any I squared in the answer. That should be replaced with -1. And that will give me 9 plus 4, which is 13. So, of course, same answer. So that's the shortcut. Then we're going to try that same shortcut for the second example. I'm multiplying conjugates, well, shortcut. So I have to take the first thing. The first thing here is -5. Just be careful and use parentheses. It's very, it's going to be like a safe way to perform this or use the shortcut. Use the parentheses. So it's -5, the first thing that's being squared, minus, always for this formula. Second thing, the second thing is 9i. 9i that I have to square. Okay, so -5 squared is -5 times -5, so it's 25. Then I carry over minus. And now I have to square both 9 and I. So 9 squared gives me 81, and then I squared. Next, I will replace I squared with -1, and I will have to multiply. So that's what I have. So it's 25 minus 81 times -1, like that. Don't forget that it's multiplication. So that means that's 25 plus 81. 25 plus 81 is 100 and 106. Well, then we're going to do the last portion, which is division. So how to divide complex numbers. This one. Now, division of complex numbers will be usually written not with the division symbol, but using the fraction bar. So 2 minus I, this complex number, has to be divided. So it means that it's going to be over another complex number, 4 plus 3i, like that. So it looks like a fraction, but again, we can think about it as a division operation. To divide two complex numbers, in the first step, we're going to multiply the numerator and denominator by the complex conjugate of the denominator. So it sounds a little too complicated, but then think this way. I want to have just a real number on the bottom. Well, we just learned that to get a real number, when we work with complex numbers, well, two conjugates have to be multiplied, right? So if I take 4 plus 3i, and if I multiply it by its conjugate, which is 4 plus 3i, then, oh, I'm sorry, this is not right, right? It should be 4 minus 3i conjugate. Well, then on the bottom, as a performance separation, I will get just a real number. And we also said, well, we can't just go ahead and multiply denominator by something. If we do that, we have to multiply the numerator as well. So we're multiplying the numerator by that same expression or that same number. So I have to use parentheses here. And that's pretty much the key step. After that is just, some manipulations, multiplications, like performing the operations. But that's essentially the key step. So let me say step 1, multiply the numerator and denominator, so both top and the bottom, by the complex conjugate, or I can say by conjugate, of the denominator. So in other words, the denominator dictates by what we're going to be multiplying. Step 2, I'll just say simplify. Well, it's meaning like perform those operations. So step 2, simplify. And let's do that. Okay, I'm going to start. I guess it doesn't matter where I start. Let's start from the top. In the numerator, I will usually end up with just 2 random complex numbers that I'm multiplying. And that means that I just have to go ahead and perform just basic, regular multiplication steps, which is essentially like a foiling. So this kind of multiplication. Don't forget that you always should end up with I squared somewhere. Okay, so 2 times positive 4, that's 8. 2 times negative 3i, that is minus 6i. Negative I times 4, minus 4i. And then negative I times negative 3i. Negative times negative gives me positive. 3 stays. And then I times I gives me I squared, like that. Now the denominator. In the denominator, we are multiplying complex conjugates. So that means that we can use a shortcut. And by the way, guys, if you're like, I don't know, for some reason, don't like that shortcut, you can always just multiply same way as we just multiply the numerator. So you will end up with the same answer. But I will be using the shortcut. It's taking the first thing. The first thing here is 4. And squaring that, putting minus. It's always minus. And then taking the second thing, which is 3i. And squaring that as well. Which means that I will have to square both 3 and I. Okay, now I'm going to move on to simplifying this further. In the numerator, I have the following. I have 8. I have nothing to add it with yet. So 8. Now, negative 6i and negative 4i, those two, we can combine. That is negative 10i, or minus 10i. And then I squared, I need to remember to replace with negative 1. So if when I multiply positive 3 by negative 1, I'll get negative 3, right? So that negative 1 will always switch the sign. So it's minus 3. I'll come back to this because now I see that I can combine 8 and 3. I'll come back to that. Let me work on the denominator. 4 squared gives me 16. And then minus, well, here I already said that I have to square 3, that gives me 9. And I have to square I, well, that's I squared. Okay, like that. Going back to the numerator. 8 minus 3 is 5. 5, and then minus 10i. That's the numerator. In the denominator, I have I squared that has to be replaced by negative 1. And as I multiply negative 9 by negative 1, I'll get positive 9. So that switches the sign, basically. So I'll have 16 plus 9. Okay, so we're almost there. So it's 5 minus 10i over 25. 16 plus 9, yeah, 25. First of all, yeah, let's kind of stop and make a note here that we did get just a real number in the denominator. We know it happened because we multiplied complex conjugates, and that was kind of like the goal here. It's, again, same way of thinking as when we deal with radicals. The only thing that now is going to be one last step, and when we're dividing two complex numbers, well, we need to end up with a complex number, right? And if I look at this result, that doesn't have a form of a complex number. So a complex number, its standard form is just two terms, real number and then this imaginary part. Here I have still kind of something that looks like a fraction. Well, the last step will be here to kind of fix that and to write result in standard form. I'll say step 3, write in standard form, which is a plus bi. That's the form I want to have. I want to have just two terms, two separate terms, and that's a real part, imaginary part. How do we do that? Well, this is what we'll do. We'll take this denominator 25 and we're gonna like apply it to every term on the top. And that's how I like to show it. So it's putting 5 over 25 and putting negative 10i over 25. So you kind of like split it into two fractions. So you divide 25 into each term. So I'll have 5 over 25, and then that minus sign I can put in between right here. Minus 10i over 25. See how like after this step, now we have two separate terms. So it's starting to look like a standard form. Well, actually it is standard form already. So now it is standard form. It's just sometimes at the end you can simplify. You know, if you end up with fractions, you can simplify them. For example, the first one, 5 over 25, I can divide each by 5. So it's 1 and 5. And here for the second one, I can divide 10 and 25, I can also divide by 5, so it's going to be 2 and 5. So my answer will be 1 over 5 minus, and right now it's 2i over 5, like that. And that's something I can box. Now it's in standard form, everything is simplified. Or I can also, and it's totally optional, I can put that i right next to the number, not in the numerator, but right next to the fraction. So it's 1 over 5 minus 2 over 5i. And that is exactly the same thing. So like Alex should accept both of them. Maybe for the second one, it's kind of a little more obvious what is A and what is B, right? So, but overall, this answer has the form I plus bi. I mean, a plus bi, sorry. A is 1 over 5 and b is negative 2 over 5. So what if we have to divide negative 2 by negative 5 minus 7i? So here we're actually not dividing two complex numbers, we're dividing a real number by a complex number. But since the complex number is involved and we're dividing by it, we're going to use exactly the same approach. So the fact that we have negative 2 in the numerator does not change the steps. So we start by multiplying top and the bottom by what? So by what do we need to multiply on the top and on the bottom?
Negative 5 plus 7i.
Negative 5 plus 7i. Very good. That's exactly right. Okay, so I will did I? Yeah, I didn't even rewrite last time. Okay, yeah, I can keep it like that. So yeah, that's what we're dividing by. Multiplying by, I'm sorry, on the top and on the bottom. Now in the numerator, multiplication will just be the distributing negative 2, like that. So it's negative 2 times negative 5, positive 10. Negative 2 times 7i minus 14i. like that. And in the denominator, since we're multiplying conjugates, we can use the shortcut. It's taking the first thing. I feel like we already did that one, but okay. Negative 5 squared minus, and then the square of the second thing, which is 7i squared. And I will need to apply square to both 7 and I. So that's 10. Nothing to do in the numerator, right? So the numerator is easy this time. 10 minus 14i in the numerator. And then denominator. Negative 5 squared is positive 25. Then I bring down negative. And 7 squared. 7 squared is 49. And then I squared. Okay, now I will replace I squared with negative 1. This will give me, okay, I'll copy down the numerator. This will give me 25. And then since I'm now multiplying by negative 1, so negative 49 times negative 1 gives me positive 49. So it's plus 49. So that's 10 minus 14i over 25 plus 49. So it's 65, 74. Okay, so yeah, so that's what we have. And this is not the final answer yet because we want to put this result in standard form, to put this complex number in standard form, and that is separating the terms. So I will put 10 over 74 and negative 14 over 74, like that. Minus 14i over 74, and then I'll check if I can simplify. They're all even numbers I should be able to simplify, so at least I should be divide out 2. Yeah, I think that's all I can do here. So 10 divided by 2 is 5. 74 divided by 2 is 35. 37. I think it's 37. 37. And then 14 and 74 I also can divide by 2. That's 7. And then 37. And then 7 and 37, yeah, I can't simplify it any further. So yeah, that's it. Just what I have here. And that means that the answer, the complex number that I get at the end is 5 over 37 minus 7 over 37i. I'll just write I next to the number. So we started with real number, negative 2, divided by a complex number. Well, the result is another complex number, but usually like the results are not very intuitive, so usually we don't see what we're going to get at the end when we perform division of complex numbers. So you just have to carry out all the steps to kind of find out what the result is.